So here are some key features when you are graphing quadratic equations. The standard form of a quadratic equation is y is equal to ax squared plus bx plus c. Now a is your lead coefficient and c is a constant. The graph of a quadratic function is called a parabola. Now, a parabola will open up if your a or lead coefficient is greater than 0 or positive. And the parabola will open down if the a is less than 0 or negative. The minimum or maximum point is called the vertex. The y-intercept is the point where the graph crosses the y-axis. The x-intercepts, or roots, are points where the graph crosses the x-axis. Now, keep in mind that x-intercepts, or roots, are also known as zeros or solutions. The vertical line that divides a parabola into two congruent halves is called the axis of symmetry and is written in the form of x is equal to a. Now, a is that number. Now, when you're graphing a quadratic in standard form, the first thing you need to do is find the vertex. To find the x-coordinate, we'll use our vertex formula, taking the opposite of b and dividing by 2a. Remember that the b and the a are coming from your standard form. And then to find the y-coordinate of your vertex, you are going to use substitution. Then you'll make a table of points. Remember to use symmetry around the vertex. And then sketch your graph. You'll plot your points and then connect using a U-shaped curve. Make sure that it's curved. Now let's do some examples together. Here you have your quadratic in standard form. To find your vertex, we're going to take the opposite of b, so the opposite of -4, divided by 2a, which is 2 times 1, and that gets me 2. Using that 2, that's the x-coordinate of my vertex, I'm going to use substitution back into your quadratic equation to find the y-coordinate. Using your order of operations, you're going to get -1. That means your vertex is at 2, -1. So that's where you'll put your first point. Then using symmetry, you'll go 1 point to the left and 1 point to the right of your vertex. So that's 1 and 3. Take either one of those values. It doesn't matter which one, and use substitution to take that value, plug it into your quadratic to find out what the y-coordinate is. I'm going to get 0, which means the y-coordinates for 1 and 3 are both going to be at 0. I can plot those points on my graph. Again, using symmetry, going 1 more point to the left and 1 more to the right, I'm going to get 0 and 4. And again, substitution back into your quadratic equation, I'm going to get the y-coordinate of 3. I now can plot those 2 points on my graph. I can make a nice U-shaped curve. Now, my axis of symmetry, again, will be that vertical line that would fold your parabola in half, almost like a piece of paper. So right around that vertex, when your x is 2, that's where your axis of symmetry is, right along that vertical line. And that vertex is a minimum of that parabola because it is the lowest point and it has a value of -1. Now let's look at a second example. Again, let's look at your vertex. So the opposite of -8 divided by 2 times -1, that gets me the x-coordinate of 4. Using substitution back into my quadratic equation, I'm going to get a y-coordinate of 8. That means that vertex is right at 4, 8. You can put your point on your graph. Next, using symmetry, go 1 point to the left and 1 point to the right. So pick either one of the values. I'll choose 3. Again, substituting back into your quadratic equation. You'll get a y-coordinate of 7. So you can plot those 2 points on your graph next. One last time, use symmetry, 1 point to the left and 1 point to the right. Using either one of those values, I'll use 2. Plug 2 back into your quadratic equation to get your y value of 4. Now that you have your 5 points, you can go ahead and make that U-shaped curve. And let's find the axis of symmetry. Now right along your parabola, or you can fold your parabola in half. When your x is equal to 4, that's going to be the equation of that vertical line. Now, because your parabola opens down, your vertex is a maximum with a value of 8. Okay, one more example. Here, your quadratic equation is x squared minus 8. But notice that you don't have a b value. That's just like saying that there is a 0x. So finding your vertex, taking each of your values, 0 and 1, you'll get an x-coordinate of 0. So substitute that back into your quadratic equation. You'll get a y-coordinate of -8 with your vertex right at 0, -8. Using symmetry, go 1 point to the left and the right. Pick either one of those values, plug back into your quadratic equation, and you'll get a y-coordinate of -7. Plot those points on your graph. And one more point to the left and to the right, you have -2 and +2. I'll use +2, plugging back into my quadratic. I'll get a y-coordinate of -4. I can make that U-shaped curve, and using that, I can then make that dotted vertical line to find that axis of symmetry. It's right along the y-axis, but the equation of that line is x is equal to 0. Now, because your parabola opens up, your vertex is a minimum with a value of -8. Here are some things to remember. Make sure you substitute the x value into your quadratic equation to find the y value, and use symmetry to find the other x values in the table. If you found this video helpful, don't forget to hit like and subscribe for notifications on new videos. Thanks for watching!